In example 2 here, we turn our attention to line graphs, and that is where the height of the dots are equal to the value of the dependent variable. So here we're looking at the quarter versus the number of users in millions of the Twitter social media platform. So I've already prepared this graph for you. So along the x-axis here, we have our quarter. So we're going from Q1 of 2010 up to Q1 of 2020. And then along the vertical, we've got the number of Twitter users in millions. So this 50 is 50 million, 100 million, 150 million, etc. So notice that we can see some patterns in the growth here over time. This is actually what's called a time series graph because your independent variable is time. So if you see that terminology, time series graph, that's just looking at what happens over time. So notice here that Twitter had pretty strong growth in users from 2010 up to about 2015, and then it kind of levels off here and really doesn't grow very much. You got a little bump from 2019 to 2020, but we see growth and then leveling off mainly. So we're easy to see those patterns of the dependent variable over time when you're looking at a line graph. So we could ask questions like, well, how much did user growth increase from 2010 to 2015? So if you were not given the actual data here, you could estimate, approximately 30 million here, and in 2015, maybe 310 million. And so you could say, growth from 2010 to 15 is approximately 310 minus 30, which is 280 million users. And then we can see that there was only a decrease in Twitter users for 2 years, from 17 to 18 and from 18 to 19. Okay, Twitter growth increased for all other years. And again, the way that we're getting this graph is we had Q1, our users were 30. So above Q1, we go up to a height of 30. So this is 30. And then for Q1 of 11, we had 68 million. So here I'm going up to 68. Now I actually used Microsoft Excel to make this graph, but if you're making by hand, that's the procedure that you would follow.